Okay, this short video is going to be more complex problems about the solubility curves. You should have already watched a solubility curve video on saturated, supersaturated, and unsaturated. This is just going to be more intense problems that you can do with a solubility curve. Now, I do want to point out that in the solubility curve graph that we're looking at over here, KNO3's line is a yellow line, and it goes something like that. So if it's hard to see on your computer screen, that's why. So just be cognizant of that as we're going through and doing these problems. We're going to do problem number 7, and then we're going to do problem number 9. All right. So if you want to pause the video and try to do those on your own, and then you can watch this video and see if you're right, great. Or just watch how I do them and go from there. So problem number 7. How many grams of potassium chlorate must be added to 200 milliliters of water to produce a saturated solution of 50 degrees Celsius? Now, I want to point out, this is asking for 200 milliliters of water. In a solubility curve, you're typically given the values per 100 milliliters or grams of water. Now, I want to remind you that since the density of water is 1 gram per milliliter, 100 grams of water is equal to 100 milliliters of water. So if we're given 200 milliliters of water, that is essentially 200 grams of water. So how many grams of potassium chlorate? So potassium chlorate, what is that? I'm going to do it one more time here. That's KClO3. All right, so KClO3 on our graph right here, this dark blue curve, we're given the value 50 degrees. So trace that up, and we see that the solubility of KClO3 is somewhere about, I'd say 21 or 22. So for the sake of this, let's say 22 grams per 100 grams of H2O. Now, you're asked for 200 grams. 200 grams or milliliters of water. So, how many grams of potassium chlorate will dissolve in 200 milliliters of water at 50 degrees Celsius? So, this value is again at 50 degrees Celsius. Don't laugh at my at sign. I know I went the wrong way. It's because I'm left-handed and I do my circles that way. So it's 22 grams at 100 grams, but if we have 200 grams, that's just double. So 22 grams is the only time I'm okay with proportions in this class. 200 grams, what's x equal to? 44. You just double it. Simple proportion. Okay. Now, that's me trying to get a new page. Okay. So, problem number 9. If 50 milliliters of water that is saturated with KClO3 at 25 degrees Celsius is slowly evaporated to dryness, how many grams of the dry salt would be recovered? Now, it's important to note, at 50 mils of water, 50 milliliters of water, we want to know the solubility of KClO3. Still working with KClO3. I didn't do that on purpose. And the temperature is 25 degrees Celsius. So I actually find it very useful to write out all these values. All right, so for KClO3 at 50 mils and 25 degrees Celsius. So the first thing we really need to do is go look up the solubility of KClO3 at 25 degrees Celsius. So 25 degrees Celsius, go right here. Boom. I'm going to say 10. It's close enough. So 10 grams, my gosh, that's terrible. 10 grams and 100 grams at 25 degrees Celsius. What about a 50? Again, simple proportion. Because 50 mils is 50 grams. It's only going to be 5 grams. So, if you slowly evaporate to dryness, or at 25 degrees Celsius, evaporated to dryness, how many grams of the dry salt would be recovered? As in, no water left. All the water's gone. 5 grams. 5 grams of the dry salt would be recovered. Okay? Now, let's look at a different problem. Yeah, number 8. Number 8 is a good one. So a saturated solution, number 8, right here. A saturated solution of potassium nitrate is prepared at 60 degrees Celsius using 100 milliliters of water. How many grams of solute will precipitate out of solution if the temperature is suddenly cooled to 30 degrees Celsius? So the cool thing here is the value of water is 100 milliliters, so no proportions. We're just going to look at the temperatures and go from there. So at 60 degrees Celsius, it's cooled to 30 degrees Celsius. Now, what are those solubilities? Well, here we're dealing with potassium nitrate. Oh, great. The yellow curve. So, at 60 degrees Celsius, the solubility of potassium nitrate is about 102 grams. There we go. 102 grams. And we're dealing with 100 mils of water, so we can forget about using proportions here. And we're going to 30 degrees Celsius. So what is the solubility at 30 degrees Celsius of KClO3? And our nice yellow curve here, which is actually about right there, not on my previously written red line, is about 48. 48 grams. So how many grams of solute will precipitate out of solution if the temperature is suddenly cooled to 30 degrees Celsius? I have a problem with the use of the word precipitate here. Crystallized would have been better, but we'll roll with it. So how much will crystallize if we go from 60 to 30? That's 102 grams dissolved at 60 and 48 at 30. So how much will crystallize out? 102 minus 48. Do that mental math for us. 54 grams will crystallize out. Now, I do want to point out, if you're looking at a key for solubility curves, you may be off by 1 or 2 digits in the ones place. That's fine, because just like when we're reading thermometers in the lab, or graduated cylinders, or manual balances, which my class doesn't use because no one uses them, then you're going to have some varying levels of discrepancy there. So just keep that in mind as you're looking at keys for solubility curves. You may be off by 1 or 2, or maybe even 3, but because it's up to the person reading the graph at that point. So that's okay. So I hope this video was informative. A little more intense problems about solubility curves. Love all my kids out there. Stay safe. Wash your hands, and hopefully we'll see you guys in the fall. Come and see me. Bye.